Hey, Andrew, just in case you're still working on stuff, I know this is an assessment, so pretty important for your grade. So I know when I write things, it doesn't quite make sense. So I thought maybe I'd give it a shot on giving a video to clarify. On number one, we've got this object rotating, right? It's a solid cylinder. Solid cylinder has a rotational inertia of 1 mr squared. On part A, what are we asking in part A? Just the angular acceleration, and you did that great, right? Angular acceleration is that change in omega over t. So, perfect. You got your 0.116 radians per second squared. But the question is, part B is what force was required? What you've got is a force, right? You've got your, force equals mass times acceleration, but that's not the equation we're using. We're wondering how much with our angular acceleration, what's the force we need to rotate the object? So you've got a force at a radius, right? And then you've got not mass times acceleration, you've got net torque, a force times a radius, equals I times alpha. Okay, now I is different from m. Okay, so I is equal to 1/2 mr squared, right? And A and alpha are quite different. Okay, so you've got the alpha, you've got the R, right? You found A, but I don't want A, right? I want torque or the net torque equals rotational inertia I times alpha. So you could rework that and get full credit for that. So let's see, part 2, you got 100%. And part 3, this is conservation. That looks like an angle. This is conservation of momentum, not conservation of energy, right? You're using the conservation of kinetic energy in lieu of conservation of momentum. Conservation of energy is going to be more, it could be associated with this initial and final, but we talked more of, you have to apply, like you've got something rotating, you're adding or you're changing the mass of the object itself. So you've got to take it down. Like, for instance, conservation of energy is about one object rotating and rolling, so it would have translational and kinetic. But this is a scenario where you've got two objects, an initial rotating object, and then you add a second object. Well, that is a momentum issue. Momentum is dealing with two objects, kind of, sort of, right? It can involve two objects. Conservation of energy is still going to be maintaining one object, okay? So hopefully that'll help you tackle this problem. And let me know if you've got questions. You can send me an email if you need